Hello and welcome to this question on coefficient of correlation. We'll try to find out coefficient of correlation for the data given in this question. So the data is organized like this: age of husbands 15 to 25, 25 to 35 and so on. And then we have age of wives 10 to 20, 20 to 30 and so on. So what we'll do is we'll try to find out if there is any correlation between ages of husbands and ages of wives. That is, we'll see that is it the case that as ages are increasing for husbands 25, 35, 65, are the ages for wives also increasing? It looks like that there is a correlation because at smaller ages we have some numbers, but for these smaller ages and these larger values we do not have any numbers. So it looks like there is some kind of correlation, and when this age increases, so we can see yes, there are certain numbers, but for these higher ages there are no numbers over here. So it looks like there is some kind of correlation, but we'll go ahead and find correlation between ages of husbands and wives. Now for the purpose, we'll be needing a bigger table. So first we'll go ahead and construct that bigger table and then we'll proceed. Now here we have our table ready. If we could zoom out, yes, this fits in complete page. So this is the table that we'll be making use of. Now if you can see, we have kept this section colored differently and the remaining sections colored differently. Now this is just in an effort to differentiate between what the information has been provided in the question and what all we have to calculate. This is the area where our calculations will run. So whatever I'll be calculating, I'll be putting it in these four areas. Here we'll be having all the information that was given in the question. So now let us go ahead and fill this table with the information given, and then we'll proceed to see what we need to do with this. Okay. So here we have our question. Let us fill it. What do we have? We have okay. So this is the information that we are already provided with. We can check here. We have age of wives 10, 20, 30, 40, 50, 60. Then we have age of husbands, which is 15, 25, 35, 45, 55, 65. Then the frequencies. When husband's age is 15 to 25, at the same time wife's age being 10 to 20, there are 6 such cases. 3, then we have a 3, 16, 10, 10, 15, 3, 16, 10, 10, 15, 7. Then there is a 7, 10, 4, 4, 5, 7, 10, 4, 4, 5. So this is the question that we have been provided to find if there is any kind of correlation between ages of husbands and wives. Now let us go ahead with solving it. Now when we have a look at this question, the first issue that we come across is the data that we have been provided here is continuous. Now whenever we come across continuous data, we are stuck in a situation that we cannot apply any formula directly on that. So what we do is, first of all, find out the mid value of this data. What will be the mid values of this data? 10 to 20. So what will be the mid value? The mid value will be 10 plus 20 upon 2, giving me 15. So mid value would be 15. Then mid value of this second case would be 20 plus 30 upon 2, giving me 25. So mid values would be Similarly, if we come here, we find that mid values would be 15 plus 25 upon 2, giving me 40 by 2, that is 20. So mid values would be here. We have our mid values. Now if we have a look at these mid values, these values are very big, and when we will try to solve them, they will become much bigger because we'll be multiplying 60 with 55 with 5, so it will be a very big proposition. So let us adjust them a bit and let us find out values of dx and dy, dx and dy, dx and dy. How we find these values? What we'll do is, for the purpose, I'll do a thing. I'll divide these respective rows and columns also into 2. Here we have divided. Now why I've divided these is, look at these values, 15, 25, 35, 45, 55. They are following a kind of pattern. So why not assume this value to be our central value or starting point or the reference point, and then find out how much all other values are deviating from 35. Can we do that? Yes, surely we can try to do that. How much is 35? Now I am assuming that this is my reference point. So how much everybody is deviating from 35? How much 35 is deviating? 35 minus 35, no deviation at all. 45 is 10 units more than 35, so deviation would be 10, and then here it will be 20. Can I find out deviations for 25? It will be 25 minus 35, giving me a minus 10, and similarly here I'll get a minus 20. So the deviations are minus 20, minus 10, 10 and 20. Yes, one good thing I've done is I have gotten rid of 25, 35, 45, 55, such huge values, and now I'm down to 20s and 10s only. But still, if I have a look at these, they all have a common divisor of 10, so they can still be reduced. So let us go ahead and divide them all by 10. So if I divide this by 10, I'll get a minus 2, minus 1, 0, 1 and 2. So what I've done is, I've taken the mid values because I cannot work on continuous data. So from these mid values, I assumed my 35 to be a reference point, and taking that reference point, I found out the deviations of all other values, and when I got those values, I realized that these values actually can be compressed a bit further to these values. So this will be my dx. Fine. Similarly, can we try to solve it for this 20, 30, 40, 50? Definitely I can take this 40 as my reference point, and if this 40 is reference point, how much more is 50? It is 10 more, 20 more. 40 in fact will be 0 because 40 is the reference itself. 30 is 10 less, so it will be 30 minus 40, giving me a minus 10. 20 minus 40 giving me a minus 20. So here we have minus 20, 10, 0, 10 and 20. Once again, same kind of values. Once again, can I divide all these values by 10? Definitely I can divide and get minus 2, minus 1, 0, 1 and 2. So dy comes to be this, minus 2, minus 1, 0, 1 and 2. Okay. Now, first hurdle crossed. I could not go ahead and work on these values directly. So what I've done is, I went ahead and found out values of dx and dy, which I can work with. So in a sense, this data is not needed from here on for calculation sake at least. Okay, this is the data that will be making use of dx and dy. Now let us write down the formula for coefficient of correlation so that we can see what all values do we need. What is the formula for coefficient of correlation? It is R, which is coefficient of correlation. Remember, we call this R as coefficient of correlation. So R is coefficient of correlation. R is n sigma f dx dy minus sigma of f dx sigma of f dy upon under root of n sigma of f dx square minus sigma of f dx whole square. This is my first term. Similarly, I will be having a term for y also. That will be n sigma f dy square minus sigma of f dy whole square. So this is the formula. So what all do I need over here? I need f dx dy, I need f dx, then I need f dy and summation of it, I need f dx square and f dy square. And what is this? This is nothing but square of f dx, this value. So I'll be needing these values. Let me write them down over here. I'll be needing an f, then I'll be needing f dx dy, and then because we have y over here, so here I'll write f dy and f dy square. Here I'll be getting f dx dy, f dy, sorry, we have x this time here, so it will be f dx square. These are the values that I'll be getting. Let us go ahead and find out these values. What all do we have? We have, to start with, we have f. This is row wise frequency of these cells, 15 to 25. What is total frequency of 15 to 25? It is 6 plus 3, 9. What is the row wise frequency of 25 to 35? Age of husband being 25 to 35. How many such cases we have recorded? We have recorded 3 plus 16, 19 and 10, 29. So let us go ahead and find out all the row wise frequencies. Here we have our row wise frequency. Similarly, what happens in case of wife? Wives with age of 10 to 20. How many such cases were recorded? 9. Wife with age of 20 to 30. How many such cases were recorded? 29. Let us go ahead and fill it. This is the data that we get. Now, if I wish to check how many in all did I survey, how many husbands did I check? 9, 29, 32, 21 and 9 from different age groups. So in all I checked 100 couples, 100 husbands, 100 wives. So this is our first measure that we will be needing. What is this measure? It is N. This is called N. Okay. So next we need f dx dy. So f dx dy looks like it is a typical proposition, but it is very straightforward. F dx dy. Now these are cell wise frequencies of all combinations. Combinations like Husbands having age 35 to 45 and wives having age 20 to 30. We have 10 such cases registered. So this is the frequency of this particular combination. Now I need f dx dy. So this is f. Its corresponding dx is -2 and its corresponding dy is -2. So what I'll do is 6 multiplied by 2 multiplied by 2. So that gives me a total of 24. Then 3 multiplied by -1 multiplied by -2 would give me a total of 6. 3 multiplied by -2, this -2 multiplied by -1, giving me a total of 6. 16 multiplied by -1 multiplied by -1, giving me a total of 16. What happens over here? 10 multiplied by -1 is -10 multiplied by 0. Because it was multiplied with 0, complete value goes away. Again, this 15 will be multiplied by 0, this complete value goes away. This 7 will be multiplied by 0, multiplied by 1. What is happening? Irrespective of what they are being multiplied, in case of dx, they are always being multiplied by as dy of 0. So their final value is always coming as 0. Okay, this 10 was left out. What happens with this 10? 10 multiplied by -1 is -10. -10 multiplied again by 0 is 0. So I get value of 0 in this case. Now let us move to this row. 7 multiplied by 1 multiplied by 0. This will give me a 0. Then we have a 10 multiplied by respective dx of 1. 1. So look here carefully. 10 multiplied by this 1 is 10 f dx and then this dy. 10 into 1 multiplied by 1. We get 10. And this last one would be 4 multiplied by 1 multiplied by 2, giving me an 8. And then similarly this would become 4 multiplied by 1 multiplied by 2, 8. 5 2's are 10, 10 2's are 20. This is our total f dx and dy. Now I actually need summation of f dx and dy. So let us go ahead and add 15 to 25. Total of f dx and dy is 24 plus 6, that is 30. Let us put a 30 over here. Then we have 22, then we have 0, then we have 18 and 28. Right? Now let us check column wise also so that we can be assured that we have found out correct values. 24 and 6 is 30, 22, 0, 18 and 28. Let me add them. When you add these, you'll get summation of f dx dy. Remember, we need summation of f dx and dy. So let me go ahead and add this f dx dy. Total would come out as 98. 98. This is another important value for us because we'll be needing it over here. This is f dx dy. Let me see if I can put it over here. F dx and dy. Let us cross check if it is same. If you add this f dx dy, see both f dx dy are coming from same data, so they have to be same. If you could check it from here, you'll get again 22 and 18 is 40, 40 plus 30 is 70 and 28 is 19. So yes, we have done it well. So out of this formula, n has been found, sigma f dx dy has been found. Let us go ahead and find out remaining values. What is this? This is f dy. F, remember, not these f's. These were cell level frequencies. Now I am going for group level frequencies. Now my first group frequency is 9. F multiplied by its corresponding dy. 9 multiplied by -2 gives me -18. Similarly, now I have f of 29 for second group. So 29 multiplied by corresponding dy gives me -29. 32 multiplied by corresponding dy would give me 0. And similarly here I get 21 multiplied by 1, 21, 9 multiplied by 2 is 18. Can we add them all? Let us add them and see. We get a total of minus 8. F dy is done. Next I need f dy square. Now look carefully. Where students miscalculated, I need sigma of f dy square. What students generally do is, they have this sigma f dy. Let us mark it separately. They have this f dy. They take this dy and square it. Now, taking f dy and squaring is not same as f dy square, because what you have done over here is you have multiplied sigma f dy to sigma f dy, while what was required was summation of f dy multiplied by dy. So I needed this, but you have found out this. This is an error that most of the students commit all the times. They just go ahead and square it and put it over here. That is wrong. This will not be square. They go ahead and square 18 and put it over here, square 29 and put it over here, square 21 and put it over here. This is not the way to go, because what you are doing is you are simply taking square of f dy. You are taking f square dy square. But I need only square of dy. Look here very carefully. We need square of dy only, and then multiply it to f. So how we do that? Take square of dy. Square of minus 2 is 4. So this square becomes 4. 4 multiplied by 9 gives me a 36. This is the correct value. So don't go for a square of 18, rather go for square of dy and then multiply it to 9. Let us check next one. Square of minus 1 is 1 multiplied by f. Dy square multiplied by f. 1 multiplied by 29 gives me 29. 32 multiplied by square of 0 will ultimately give you a 0. 21 multiplied by square of 1. Square of 1 is 1 multiplied by 21 is 21. And last case becomes 9 multiplied by square of 2, which is 4. So 9 multiplied by 4 gives me 36. So this is the correct way to find out f dy square. Now if you have a look at this thing, what is this? This is f dy multiplied by dy. Simply f dy multiplied by dy. Let me see what I am saying. F dy, you have it, multiplied by dy. Minus 18 multiplied by minus 2 is 36. Minus 29 multiplied by minus 1 is 29. 21 multiplied by 1 is 21. 18 multiplied by 2 is 36. So you can go either ways. You can either find out squares of dy and multiply them to f, or you can take this f dy and then multiply it to dy. So we already have f dy. Once again multiply by dy, it will give it f dy square. So you could pick either of these approaches. We will practice these approaches in videos to come. For the moment, let us find out f dx. Task on hand. F dx, f multiplied by dx, 9 multiplied by minus 2, giving me minus 18. 29 multiplied by minus 29 multiplied by minus 1 is minus 29. 32 multiplied by this 0 is 0. 21 multiplied by 1 is 21, and 9 multiplied by 2 is 18. So these are my values of f dx. Now can I go ahead and find out values of f dx square? We'll pick a shortcut this time. f dx multiplied by dx. Minus 18 multiplied by 2, 36. Minus 29 multiplied by 1, minus 1, 29. 0 multiplied by 0, 0. 21 multiplied by 1, 21. And last one would be 18 multiplied by 2, 36. So you can go in this way fashion, or you can go in conventional way, that is squaring the dx and multiplying 12. Let us find out what are these totals also. We have missed out on f dy square also. Let us find out these totals. What are these values? This is f dy square. This is f dx square. This is f dx, and this one is f dx square. So I have all these values available with me. Let us highlight them. All these values are now available with me. Let me go ahead and substitute these values and solve them. What do we have? We have n. N is 100. Multiplied by sigma of f dx dy, summation of f dx dy. This is f dx dy, 98. Then there is minus summation of f dx and summation of f dy. Summation of f dx is minus 8. Summation of f dy is minus 8. Both are minus 8 incidentally. Summation of f dx, summation of f dy. Then what do we have? N multiplied by f dx square. F dx square is 122, n is 100. So we get 100 multiplied by 122 f dx square. Then there is a minus sigma f dx square. F dx is minus 8 and square of that. Minus, we have this minus for formula. Then this is minus 8 square. And then same thing happens with f dy also. We have 100 multiplied by f dy square, which is 122, minus f dy whole square. We have f dy here. Here we have f dy whole square, minus 8 whole square. This is the formula that we need to solve. Let us go ahead and solve it. So here we have our coefficient of correlation. This was our pigeon box or kabutar khana as we call it. Now you can see why we call it a pigeon box or a kabutar khana. Look at the amount of figures that we have in this table. In any case, this was coefficient of correlation for our continuous data, grouped data. Next time when we meet, we'll practice another question for coefficient of correlation for grouped series. For now, this is our coefficient of correlation. Thanks for watching. Bye-bye.